be skeptical about the judgment without having read the article. But anyway, Justin, go ahead, please.
Okay, I just wanted to ask you about this theory that to me makes the most sense about like asteroids and things that we're finding on like the moon and also even Mars. Have you heard of something called the hydroplate theory?
Hydroplate theory?
Yeah. Uh,
No, I haven't.
so basically, it's a theory that at one point in Earth's history, there was a bunch of water within the crust of the Earth, like that was at least three times the amount of ocean water that we have today.
Hmm.
And eventually, that water, or excuse me, the crust, kind of cracked and then spewed out so much water that the water, with all that pressure of the continental crust pressing down on it, at least like maybe 60 miles worth of it,
Oh,
um, pushed
all right.
down on it and then caused the water to shoot up at a supercritical mass. And also, it brought up a bunch of boulders and brought a bunch of like, I guess, like land and so on into space, which eventually became much of the asteroids and the comets that is now kind of spinning, kind of circling around our solar system. So at first, the theory sounds ridiculous,
Yeah.
but then when you consider the fact that they found amino acids on some asteroids
Mm.
or meteorites, they found like kind of things like material that you would only find at least on Earth because it requires like perfect conditions for those
No,
to
it
happen.
doesn't. Yeah.
Okay, well, yes, I would like to ask you about that. Like for
Yeah, yeah,
example,
yeah. Oh, that's great. I love that. I love it because it's wildly wrong, and I can explain why. But I've never heard of it before. Okay, so there's so much wrong with it. Uh, uh, the so I'm really curious as to the source.
a
As
guy
to
named Walter Brown. So if you
uh,
look it up, Walter
okay, let
Brown
me do that.
hydroplate.
That's great because uh, before I get myself in trouble, uh, uh, Walter Brown, uh,
Yeah, maybe a variation of Walt Brown.
hydroplate, Hydro. Oh, okay. Well, okay. The first thing I found was Walter Brown's hydroplate flood model doesn't hold water. Is the first thing I found. Okay. All right. So I'm looking at that rather than his theory. So I'm just reading the headlines here. It says introduction, major problems from the start. Uh, 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 okay, so I don't need to read this article too much to I can use what you said, okay, as the information that I can work from. Okay. Uh, Although there's a lot of good stuff here. I mean, this is nice. So this is much more than I would have had to say, but I can say it from my point of view. Okay, I'm not going to read the article. I'll tell you what. I'll tell you what I have to say based upon what you said, rather than what he said. Walter Brown. Okay, uh, so the main thing that's wrong with the one of the things you said is uh, hold on, I just want to make sure that I'm still on Clubhouse. Yes. Okay. The main thing that's wrong is the amino acid bit. Uh, it is uh, it is a well-known fact by anyone but apparently him that amino acids are not only uh, the stuff from which life is built, but also the stuff from which the universe is built. Turns out that the universe is filled with the stuff. It's not just local to Earth, it's local to the universe. And, and one of the ways that that was determined, aside from, uh, it was determined experimentally for that matter, by a guy named Miller and Urey about, 50, 60 years ago. And what they did is they took the gases that would be found in primordial Earth and they subjected them to a lot of shaking, a lot of lightning, a lot of uh, 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 infrared, X-rays, anything they could subject it to sort of cook it. and they cooked it for a couple of days, and then they looked at the stuff and it turned brown and orangey brown, and then they took that stuff and analyzed it and found out that it had made 20 of the 24 amino acids that we in fact are built out of. So within just a few minutes, days, they had built most of the amino acids. And subsequent work has built the rest of them using the same uh, type of experiment in which you do nothing but shake and subject to light and heat. And meteorites contain that stuff all the time. Yeah, it comes down from meteorites, but it wasn't up from Earth. It's just that this stuff comes down from meteorites because that's found everywhere. So
Wait, but wouldn't you need the conditions that you found in that was done in that experiment? So if
nope,
you need
all you need,
war,
nope,
water, and
nope, you don't. All you need is the carbon found. It's found. Radio telescopes can detect this stuff in galaxies far away, in clouds, molecular clouds nearby. This stuff can be detected by telescopes.
amino
Is it?
acids,
Yep. Well, the precursors of amino acids called PAHs, I don't know how to tell you what that is. Polyaromatic hydrocarbons. That's it. That's what Pa is. And so they're able to determine the precursor to amino acids uh, easily. And as far as amino acids are concerned, I think that they have perhaps discovered one or two with radio telescopes. But as I'm saying, the universe is filled with this stuff. It's not a mystery. What so so when you're imagining life on Earth, you don't need to uh, do anything to have those building blocks here. What you'd have to work with is how did those building blocks end up producing nucleotides, which end up producing DNA. DNA. That's what you have problem with. But the amino acids, no problem at all. Okay,
well,
so that's the first little problem.
didn't you suggest that it had to be like their experiment? They try to replicate the primordial Earth.
Yes,
So then, therefore, like any other kind of condition wouldn't fit that because, like, if the ones that if the experiment was making it like how the Earth was to
yeah,
actually create that,
yeah.
then the vacuum of space is definitely not the primordial Earth where it had sunlight, electricity, and all these different things that's actually powering it. It's out in the coldness of space.
No, no, coldness of space. So that takes a long time in the coldness of space. So that, so what you do is, look, we've just brought back some uh, uh, stuff from an asteroid, right? We've just brought it back, and we're busy taking it apart. And this is not the first asteroid we've taken apart. And we found amino acids in the other asteroids that we've taken apart. So it's not like we haven't, in fact, investigated the stuff. It's out there. It's everywhere.
But where did it
Uh,
come from, though? Like it didn't just
because
didn't
it because nature builds this stuff out of carbon, oxygen, and hydrogen. That's all you need.
with no
Car-
water.
you you don't need water. No. And
So then,
but wait a second.
and
I take that back a second. Look, the outer planets, the outer planets, and I'm talking about asteroids all the way up to Jupiter and beyond, had water, and they have liquid water. Uh,
warm water.
Yeah, yeah, yeah. For example, Ceres, the asteroid Ceres. If you look at a picture of Ceres, you'll see when we got close to it and we flew by it and eventually didn't just fly by it, we flew around it and we orbited it and we're still orbiting it for that matter, as far as I know. Uh, you can see in the pictures of Sears, and by the way, you can get a video, a simulation from NASA. You look at a thing called NASA's Eyes, and you can actually fly around Sears in a simulation. And when you fly around Sears in a simulation, you will see two little white dots. And those white dots are ice volcanoes on Sears. So what's inside of Sears? Water, water, liquid water to this day. So all you have to do if you need liquid water to build anything, what you do is you start with it in a molecular cloud. You have it start making a star. It produces a flat pancake of which the planets and the asteroids get created. In the first 100 million years, there's millions of these objects. Some of them form into planetesimals, some of them the size of sears. Those planetesimals have water inside. Even though it's awfully cold on the outside, there's water inside. And why is there liquid water inside? Because there's radioactivity that's literally heating up these things. We have iron meteorites. How do you think those things formed? Those iron meteorites formed in the center of planetesimals, which were subsequently destroyed by collisions. So those iron meteorites formed in the center of a planetesimal that had water. So most of the objects in the solar system have water. You know, in fact, there's probably no exceptions as far as I know. Uh,
Pluto.
Pluto is not an exception. No, it's not an exception. It's not an exception. It has uh, uh, what is it? Methane, nitrogen volcanoes, I think. Uh,
I think
but
I read
but
that Pluto has
but
water.
but it has water. Everybody knows it has water.
Okay.
Uh, and so if you think about it, Pluto's got life below the surface. We just can never get to it. So anyway, so amino acids are formed everywhere, probably in aqueous environment. I may have misspoken. Okay, I was just assuming it wasn't necessary, but then I, in fact, don't need to make that statement. Aqueous environments are there, you know, uh, and so amino acids are like everywhere. You don't. It's you can look it up. It's not a mystery. It's what nature. It's. I think it's interesting. I think
Well,
it begs the question of whether or not the universe was made for us. Because it seems as if the universe has, if you will, in mind creating life, because amino acids are the first thing it does as soon as it has a chance. And when it's building a star, when it's building planets, it builds amino acids just to give life a head start. I think it's funny. I think the question is, and I'm sorry that I won't live and Carl Sagan didn't live to get the answer, but either life is the rule or the exception, and we won't know until we find the other life form, and until we do, it'll probably be a long time before we can answer that question. And just let me say one more thing about this, and I'm going off, but I was reading my favorite guy, whose name is Ethan Siegel, who publishes a blog called Ask. It starts with a bang, is what he writes, and you can find him and subscribe to him. But one of the things he wrote recently was the question of where all the life in the universe might be, given that we haven't seen anything yet. And he points out in this article, which I had never seen pointed out quite as strongly, by doing the numbers and giving the low probability to all the things that would be necessary for something like us to be found in elsewhere in the universe. He gives it such a low probability that in the end he says, given all of these low probabilities that I've assigned to every step in the building of intelligent life on this planet, there is a possibility that there isn't any other intelligent life elsewhere in the visible universe. And I like that one. That's I never went that far about, talking about it, but the idea that we might be that unique never crossed my mind before. I always thought that, well, there's lots of them out there. Every galaxy has at least a couple of intelligent lives, if not more. But he went further. He said, no, maybe not. Maybe we're the only ones. And I think that would be really tragic because we're about to kill ourselves, as a species. Anyway, I'm sorry, Justin, to have gone on. Continue uh, cross examining me because I didn't hardly explain any more.
okay. Yeah, because I was looking into the amino acids that they found, and I think they found glycine, which
Yep.
is normally found in organic matter of plants.
And
And so, in order for that to be made, there would have to be plant life somewhere out there in the solar system, or if we just assume that it was produced by some planet, out in another near another star, we have to say
no,
it's light years, from another place. So I
Just
would say Occam's razor would suggest it came from Earth.
but glycine. See, I'm not familiar. Are you saying to me that glycine was found elsewhere and it had to come from Earth?
Yeah, the type of amino acid that they found in these meteorites and these asteroids was an organic
Yeah,
type of
but you're
amino
then
acid.
taking but then you're taking another step and you're saying it had to have come from Earth rather than it was formed in situ.
Yeah, because it's the closest thing that actually produces that type of thing is Earth. For us
It,
to say it came from a whole nother
yeah, but
world, which is light years away, that would take way more explaining.
you're telling me this. I don't know. See, I have to take your word for it because I didn't read the article that you're reading. So, are you saying that the article that you read, which you know I don't have in front of me, said that the only way to explain the glycine is from having come from Earth?
Well, no, that's not their conclusion. Their conclusion, anybody's conclusion would be it just exists there, and let's not talk about it. Let's just assume that amino acids is from other places. And I'm saying that would be the wrong conclusion because um, if we say that it comes from another planet, that takes more of a miracle than
Yeah,
it
no,
came
no, no.
from
See,
Earth.
it would if it came from if glycine was required to have come from another planet via some sort of life thing, that would be one hell of a story because it would say, in short order, that life has been found elsewhere. But I don't think that that's what that's saying. I think without the story in front of me, I'll say to you that I think it says that glycine was produced naturally elsewhere by normal astronomical processes and is nothing to be remarked upon except for the fact that, ooh, look, glycine, it did that also. Yow, yippee, but nothing, no implication about life or formation elsewhere in an unusual way. I think it would say that's the rule rather than the exception.
I'm
Again, I don't
reading
know
Well,
the article.
interstellar clouds.
Yeah, it would be formed in interstellar clouds. All interstellar clouds are full of organic material, and to the extent that that stuff can be produced in a cloud, remember you've got millions of years to do it, hundreds of millions of years, billions of years to do this. Okay, you have billions of years to put together glycine in a molecular cloud. It doesn't, or if not in the molecular cloud, because I don't know how it was produced, maybe only a few hundreds of millions of years on a liquid water planet, which can produce it on its interior and then get exploded out to the outside. It doesn't require life, because if it did, it would be an argument for life, and it's not. I've never
well,
heard that argument that glycine is found elsewhere produce is an argument that life was elsewhere. It's not even, I've never heard that. So I don't think
well,
it's
I mean, it's
evidence.
just by just deductive thinking, because if you look at all the type of amino acids, that's the kind that is produced by plants and other organic, life. But another thing is that
No,
the
it isn't.
Goldilocks.
I just said the opposite. It's produced naturally without any processes at all, and just by the natural processes of chemical interactions. It does not require
Right.
life. Anyway, go on.
Yeah, and then also the Goldilocks principle that the Earth is in the right place
Hmm.
to actually host life.
Yeah,
If we just then therefore say, well, then all places is Goldilocks, that even the Oort clouds, that's a perfect place to actually
sure.
build life.
You
Then
could have
there's no
that.
point of even suggesting we're in a Goldilocks because
Well,
you can have
The
life in
Goldilocks
coldness of space.
the Goldilocks zone has had its day in court and it has come up guilty, or innocent, whatever. The Goldilocks zone is just a fiction that helps scientists talk about something that they all know better about. Goldilocks zone means the Earth and maybe a little bit of Venus and maybe a little bit of Mars, and it's cute and it's sweet. But frankly, now we know that there's water on pretty much every moon of the solar system that's larger than a certain size, and 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 for that matter, Enceladus, for one, Europa for another, could have life below the surface. So we don't we don't really we're talking about life on the surface, but we don't really think it's necessary that life be originated on the surface because we have, you know, the subterranean, you know, in the oceans, we find these life forms that could have, in fact, been the origin of life on this planet, for all we know, because we don't know. Uh, so, so Goldilocks zone is just is is this is why you want the Goldilocks zone. If you are busy building an intelligent life form that can eventually learn how to build radio telescopes to communicate themselves with us, they better be living on the surface in an atmosphere that isn't too hot nor too cold. And that would give them, so maybe that's where you want the Goldilocks zone. Not for life, but for life like us. Because we need life like us to communicate with us so we can see where there's other intelligent life out there. Otherwise, we really don't need the Goldilocks zone, you know? And the Goldilocks zone is quite fictional. For example, if you have a planet that's really close to a star, like most dwarf stars have planets that are tidally locked, that in the tidally locked terminator zone, where the zone between light and dark, that zone is just right temperature to, in fact, have a, you know, Goldilocks. So Goldilocks zone is, you know, as long as we don't point at it too carefully, it's okay. But as soon as you start looking at it carefully, it's just uh, so much conversation that's good to talk about, because when you write these articles, you want to say we found 3 planets in the Goldilocks zone, and it makes a good headline, you know, but it's not important.
Talk about it.
Interesting.
And further, but it is important again. If you will look, let's say you found a planet, if you found a planet in the Goldilocks zone and it had life on it, well, you'd be able to see things like it would change it maybe it would change its color with the seasons, you know, and so we could see life growing on it. There's lots of good things about the Goldilocks zone, but you don't need the Goldilocks zone. You just want the Goldilocks zone because it makes the conversation so much more interesting, you know. Life exists there, and it's producing these methane, and oh, methane is being produced, oh, it must be produced by life, you know, and that planet has liquid water on its surface, and oh wow, it must be, you know, you can do that sort of stuff. But you need the Goldilocks zone for that conversation. But anyway, going back to your original thing about this thing. So then you have all this water on Earth, and it has to erupt and leave the Earth in somehow crazy fashion. And I would point out that that's a lot of energy that you have to impart to liquid water, which will uh, resist being thrown out. I used to live on the 4th floor of an apartment building. And as a kid, I used to pour glasses of water out my window. And as the water increased in speed, one of the things that happened to it is it fragmented into smaller droplets. And then just before it hit the ground, it fragmented one more time. So if you're saying that you can throw an ocean of water off the earth, I say, no, you can't. No chance can you do that.
Well, it depends on how much water you're talking about. If we're talking about, let's say, a fire hydrant shooting up, high in the sky, yeah, depending on what the pressure and then also how much water it's is, behind it, that would determine like whether it's going to spray and turn into vapor, or is it just going to be like one pillar of water. So it's all about the numbers. If we're just guesstimating in our heads, we're just going back to our faint imagination of how we think water is going to react with our level of pressure that we're applying. If you use your weight to just jump on, let's say, a bottle of water or just squeeze it, then it's not going to go high. It's only going to go to like maybe your ceiling. But if you're using the pressure of like, whatever they're using for fire hydrants or or fire trucks, it can get up to like the 10th floor or
Yeah.
whatever. So if we're
Let me
talking
ask you,
about,
Justin. I'm curious as to why. I mean, I'm busy trying to debunk it, and what I'm realizing now is that you're sort of wedded to this theory, and I'm curious now as to why.
to me, it makes a lot of sense of the whole thing,
What is it
or at least this.
what is it that you think this thing answers that makes sense to you? In other words, what is the question that this is an answer to for you?
Pan-
Well, the topography of the Earth, and also the topography of the Moon, and also Mars, and many of the asteroids that we see.
But
Um,
why don't you accept the more conventional explanations that are well known and well respected, rather than this, if you will, crackpot? And I think that's fair to say that explanation.
well,
Why do you want to go with a crackpot explanation, which has, if you will, a lot of implications all over the place, rather than a series of complicated but well respected explanations for the same phenomena?
because it's complicated doesn't mean right, and well known doesn't mean it's right, and also well accepted doesn't mean it's right.
Right.
And just think it through. Like many of the unanswered questions usually points to huge contradictions. But what happens is people say, well, just pause right there. Let's just wait for the answer, maybe in 10 years or 20 years or 30 years. When really you can do that for every theory that sounds like a crackpot. Like my theory, I could say, look, it doesn't make sense now, but let's wait till, I guess our geologists, our astronomers, astrophysicists, or whatever, figure this out. So it, I just think this theory it answers more of the questions that the conventional thought actually does.
Well,
are you
I,
referring to panspermia?
yeah, panspermia, you're
I
right.
really-
But
no, I don't know about that.
Justin, you are there are a group of people on this planet, of which you are one, apparently, who prefer to uh, deny the known and well-respected science in favor of things that seem to have more sense to them. And that it clearly seems to me that you're among that group of people who subscribe to a set of theories that are not well respected, and are generally thought to be, by well respected people, to be crackpot theories. And there are lots of those things, crackpot theories, out there, and there are lots of adherents to those crackpot theories. Uh, and you apparently, unfortunately, are one of those adherents to a crackpot, or probably more than one crackpot theory. And you don't have to be. You could I could explain to you, and I would be happily like to explain to you some of the reasons for all the phenomena that you just mentioned. For example, the craters on the moon. For example, the craters on Mars, which you mentioned as part of the evidence that you were pointing out. Uh, you seem to be saying that the craters on Mars and the craters on the moon need explanations that we don't understand. Whereas, in fact, we do understand the origin of those things, and in fact, the origin of all the geological formations on the Earth and the moon and Mars. Despite the fact that you may feel that we don't understand those things, we do understand those things. I may not be the expert in all of those things, but I can go some distance to explaining every one of those things to at least the satisfaction of I think, the people in this audience.
But Dr. Laird, don't we have evidence that water has left the Earth in the form of the moon, and there's ice
This,
on the moon
the ice
from
on the moon, the ice on the moon came from the sun, my boy, not
I, I,
from
but the moon
And so did
wasn't
the
the moon
water on the Earth.
yeah.
what wasn't the moon formed from a collision with Earth?
Yes, it was, but it didn't capture any of the water on the Earth. That was boiled away in the process. So the water on the moon is the water on the surface of the moon is comes from having captured the water that that comets emit when they pass by, when hydroxyl molecules from the sun, that's OH, land on the moon, and they constitute a layer. They combine with the surface of the moon rock, and they become a not water H2O, but a molecule which contains oxygen and hydrogen, which both of which are very valuable to to NASA, but not necessarily H2O. That could be found as well, but we don't know whether it's H2O or something,
Well,
some other version. But those two molecules or atoms are very important.
But isn't
No,
OH a gas?
yeah, but when it's combined with oxygen, it's an ion, and when it hits the moon and combines with any mineral on the surface, it becomes some sort of hydrated mineral on the surface. So I don't listen. I'm not a geologist, believe me, and so I'm saying is the water on the moon. The question is it a thin candy coating, or is it go down any kind of depth? And we don't know. We think it's not trivial because that experiment has been done. So we know it's not a trivial amount, but we don't know how much it really is. It could be just down a few meters, a few tens of meters at the most. But the moon itself, as far as we know from our astronauts having been there and come back with stuff, is dry as a bone. Uh, and 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 the Earth did lose water, but only a little over its time period. Whereas Venus has lost all its water during its formation. So that, if you will, is a bit of a mystery as to how that happened, but it's not too much of a mystery uh, because Venus doesn't have a magnetic field. So magnetic fields keep stuff in, and Venus doesn't have a shield, so it lost its water. We have a shield, we keep our water. Uh, Mars doesn't have a shield, it lost its water, also doesn't have enough gravity. uh, uh, Justin, the craters on the Earth and on the Moon and elsewhere are formed because when the solar system was invented by the Sun, it created trillions of objects, some of which were planetesimal in size, and some of which crashed into us many times. The biggest one being the crash of a planet-sized object that hit the Earth and we got the Moon out of it. But the moon has craters that indicate that gigantic planetesimals hit it. Same thing with Mars. Mars has a crater on it that's half the size of Mars. I mean, all of this stuff is explainable by simply the leftover debris from the solar system. You don't have to go anywhere extraordinary to be able to explain this stuff. You just have to read the right stuff, Justin.
well, yeah, some things are explainable. I think we both have models that can explain it. The question is which one explains it the best.
Yeah,
And
the ones that
what
are written by scientists,
Well,
Justin.
yeah, I believe the ones like, for example, Walter Brown, he's a scientist. Of course,
Yeah,
everyone's a
by the way,
scientist until you don't agree with
there
them.
are crackpot scientists, and there are scientists who weren't crackpots who became crackpots in later life. Okay, so it's just because you're a scientist doesn't automatically make you not a crackpot. It just means that there's less crack. Most crackpots are not scientists, and some are. You know.
Right, right. But the question is, the point is, you have to look at what they say, not who they are exactly.
Yeah, but
But
see, the thing
the,
is,
the,
Justin, you can't look at what they say because you're not a scientist. I actually am.
well,
I
that doesn't mean
actually
I just believe you. I mean,
no no
I have
no
to
no.
use my own thinking.
But I see. But I have an education in this field, astronomy, not in geology, not in theology, not only in this field. And my education gave me a PhD, which says I can at least rant or rave about it. But in fact, what I come from is an education in physics, in math, and I've been studying this stuff using the right materials for I don't know 60 years, if not more. And
Right.
so I'm really a goddamn expert. I
Okay.
really
Well,
am.
hey,
Maybe
I respect that.
right.
What
So
matters
when I
is that
tell
your
so
arguments have to win me over, not
what,
your
no, no, I
pedigree.
understand. I'm arguing from authority, but I would like to. if you would, ask me another question, I would like to, if you will, continue to this conversation. But in fact, if you ask me a question about these things, in some of the things you believe, I would be happy to try to explain it to you in such a way that it would not seem to you that I was simply arguing from authority, but arguing from, if you will, a set of knowledge that you could then look up. Because what I can do in this room that is really interesting is I can tell you stuff that you can look up, and I can tell you how to look it up. And usually, one of the best sources for this is Wikipedia. So you can look up craters and find Wikipedia, okay? And Wikipedia will tell you how craters are formed. You
Yeah, I
can,
think we're all familiar with how it's formed because it's been like, it's pretty it permeates our media. It's on the History Channel, and like everyone's seen how the universe is made and so on.
well,
But
History Channel occasionally puts bad stuff up as well as good stuff. They don't
yeah,
care.
but when it comes to astronomy,
Oh
it's
no,
not like
no, they
someone's
have to.
gonna
Sometimes,
like
sometimes they lie. Nova is good. History Channel sometimes really bad. They don't
yeah, but
mind.
when it comes to the formation of the moon, pretty much every
It
explanation
was
sounds just as bad.
aliens.
Yes.
But
Okay. So how did the moon form, as far as you know? Because I just want to check if it's on the same page.
I'm sorry, what's the
How did the
question?
moon form?
Well, I mean, as far as I'm a Christian, so I just believe that it was formed by God putting it there.
Right. So
How
that's not, you're not going to find that in Wikipedia, right?
well, no, you won't find that in Wikipedia,
Right.
but
Which is my
I mean,
source for this stuff. Is if you consult, theology, we're not. By the way, Justin, when it comes to theology versus, astronomy, there's no intersection. You know the term Venn diagram?
I would say there's an intersection.
None.
If
There's
he's
none.
part of the story, then
No, there's none.
he'll be part of the science behind it.
There's no intersection between religion and and science. None.
Well, that'll be another subject, though. I kind of wanted to
Well,
stay on the moon
well, you should look
part.
that up too. You should ask the Google whether what the intersection between religion and science is, and look that up and see if you can find one. Because I haven't found one. So if
I
you
found one.
no, so if I ask you the question where the moon came from, and you offer up that it came from God, then we have nothing in common. We have nothing to talk about.
Well, me and
And
you may not, but
no, no,
someone else may.
what I'm saying, and I do not mean by saying that I can prove you wrong. I'm saying is that nothing I say can be taken as evidence that you are wrong from your point of view. And that makes sense. And that's what I'm saying. We cannot talk. We are not talking about the same subject. We're not talking from the same point of view. We have nothing in common. There's no point to the conversation we're having now, for that matter. None at all. All we can do is
Well, I
yell at each
mean,
other.
But
it's sort of like explaining how a fire starts. You can explain how a fire started by saying that there was lightning and it struck a tree and then boom, it spread across the land, and that's how fire starts. And then therefore, every time you do see fire, you just say, "Oh, lightning struck." But if I said, "Well, hold on, a human being set this like on purpose," if you just eliminate human beings or some intelligent being actually setting it on fire, then that will skew your science. Every time you investigate, you will always leave out something out of the equation that could possibly be the reason for why it is. So, I mean, I see God as that human being who could set the fire and just go
Yeah, and
on.
and that's
And
and
then,
that's why. So let me say this, uh, Justin. I have been talking to you for quite some time. It is not fair for this can go on
that's why
forever.
I wanted to focus on the moon because we went
Uh,
to so
Okay,
many
so
Sorry
what
about
detours.
do you
that.
want to focus
I
on?
think a dog cannot talk to chicken. It just there is no point argue about that.
No, no, I
I'm
agree
sorry
with you,
about
John.
that.
I
Yeah.
agree with you, John. But I'm tempted because he asked a question about the moon, but then on the other hand, he said that God created the moon, and so
I
I
didn't want
have
to veer
nothing.
to that. I
What?
wanted to talk about the hematite, how, and then also the fact that there was more impact craters facing the Earth than there was on the opposite end.
Right.
And the reason why that's significant is because if there were asteroids coming from the outside, it would have at least it would hit the outside of the moon, at least that's
Thank you.
behind us.
Thank you
And
very
but
much for thank you for your opinion, Justin. But I don't agree with you, and neither does science. Okay, so
Uh,
you have a good, nice opinion. I thank you for offering it, but it's not science. It's your opinion. You are, and as such, I am now going to say to you that I would like to conclude this conversation with you, and I'd like you to welcome you to stay in the room, but I don't want to have this conversation any further because really it's not fair to you and it's not fair to the other people in the room that I should harangue you with this. But I have to say, I'm very pleased that I didn't piss you off with my behavior. Okay, so I'm happy that we didn't get into a fight, and that's very good for me, and I hope it's okay for you. Uh, so let's just leave it right now, and not talk anymore, and just go with somebody else in the room if you can deal with that. Thank you.